This lecture is about software reengineering. Software reengineering is an important activity of software maintenance. It is a process that restructures a software system or component to improve certain aspects of the software. As Lehman's laws indicate, software systems undergo continual changes. These cause the structure of the software system to deteriorate. As a consequence, the software system becomes more difficult to comprehend and more costly to maintain. In this case, it is necessary to restructure the software system to reduce the maintenance costs. Reengineering objectives can be 1. Improving the software architecture. One important software engineering objective is to improve software architecture of an existing system. The need for improvement may be due to different reasons. Improving software architecture is achieved by applying architectural design patterns, security patterns, and software design patterns. 2. Reducing the complexity of the software system. Studies indicate that the complexity of a system has significant impact on the quality and the security of a software system. If the cyclomatic complexity is high, then the function is difficult to understand, implement, test, and maintain. Many patterns can be applied to reduce complexity. These include the observer, state, strategy, and other patterns. Improving the ability to adapt to change. This includes the application of appropriate design patterns to improve the structure and behavior of the software system so that it is more adaptable to changes in requirements and operating environments. 4. Improving the performance, efficiency, and resource utilization. During software operation, data about various aspects of the system are collected and metrics are computed. This information is valuable for identifying places for improvement. Architectural styles, patterns, efficient algorithms can be applied to improve the system. 5. Improving the maintainability of the software system. Many patterns can be applied to make the software system easier to maintain. These include abstract factory, bridge, builder, chain of responsibility, and more. A typical software reengineering process is shown. It involves the following activities. 1. Identifying places that need improvement. First, the software is analyzed to identify places where improvement is needed. Several tools are useful for achieving this task. 2. Selecting an improvement strategy. Next, improvement strategies are developed for the items that are identified for improvement. Often more than one improvement strategy exists per item. The improvement strategies are analyzed to assess their change impact and the time and cost required to implement the strategies. Based on the analysis results, the improvement strategies are selected. 3. Implementing the proposed improvements. The proposed improvements are implemented. Testing and regression testing are performed to ensure that the re-engineered software system satisfies the requirements. 4. Evaluating system against objectives. The modified system is assessed against the objectives. If further improvement is needed, the process is repeated. The objective of this case study is to improve the OOTWorks environment using the OOTWorks tools. The reengineering objectives are taken into consideration. The case study performs the following steps. 1. Identifying places that need improvement. 2. Selecting an improvement strategy. 3. Implementing the proposed improvements. 4. Evaluating the system against the improvement objectives. First, the OOTWorks metrics calculation tool is applied to identify places that need improvement. The tool indicates that places need improvements. One of these is the extremely high complexity of the methods of the metrics calculation class. To understand why the method has such a high complexity, closer examination of the code is performed. It is revealed that the methods use conditional statements to test if a metric is selected. If so, it calculates the metric. The complexity reflects the use of 38 conditional checks to determine which metric is computed. The next step is to select an improvement strategy. The use of conditional statements implies behavior variation, that is, different metrics are calculated using different algorithms. This suggests that the polymorphism pattern can be applied. To handle behavior variations without using conditional statements, one must define an interface for the behaviors that vary and let the subclasses implement the behavior variations. Thus, the abstract class called metric is defined. The subclasses of metric implement a method called compute metric to compute the concrete metrics. Moreover, the subclasses are the action listeners of the respective metric selection widgets, which are checkboxes. Finally, the tool is applied to assess the complexity of the modified class. It shows that the complexities of the computer metric method and the subclasses are low. As expected, about 40 new classes are added. Conventional approaches treat maintenance as post-development activity. For an agile project, maintenance begins with the delivery of the first increment or release. Development is maintenance, and maintenance is development. Maintenance process models also have requirements, design, implementation, and testing phases as the development process. This implies that agile principles are applicable to development phases, are also applicable to the phases of the maintenance process.